Welcome back, class. In today's lesson, we are going to go over one of the most famous examples of recursion with a return, something that almost every single computer science student learns at some point. This is using recursion to solve the factorial. This is recursion with a return. And today we're going to talk about factorial. Let's take a quick moment and recall what a factorial is. Well, you may have seen this in your math class, and we will have a number, say n factorial, and n factorial will equal the number n times n minus 1 times n minus 2, all the way until we get to 0, where 0 factorial, this is going to equal 1. So let's remember that 0 factorial is equal to 1. So any number we have will multiply all of its constituent numbers down to 0 and put them all together. So for example, if we have the number 3 factorial, that would equal 3 times 2 times 1 times 0 factorial, which is 1 again. So times 1 times 1. So this very easily is going to give us a value of 6. And you can see that this number grows very quickly and has a beautiful pattern of getting smaller, which in the last lecture I talked about the value of using recursion when problems get smaller. So how can we solve this numerical problem with a recursive method? Well, it becomes actually quite simple to solve this problem. So let's create a public method. And this method is going to have a return type of integer, since we're going to be dealing with integers, public int. And we'll go ahead and call this factorial. And we're going to pass in an integer. And we'll use our friend n again. So we need a couple of key components to our method here. So some key components, let's think about what we need to do. In a factorial, another way we can think about breaking down this problem is not just n and n minus 1 and n minus 2. We can actually think about this also as any n factorial number equals n times n minus 1 factorial. Well, you might already be seeing something here. We use this same n minus 1 pattern in our last lecture on recursion. So we can use our n and recall and use a method called to n minus 1 factorial. So we can do this. We can say return our n times a factorial of n minus 1. Seems like we've solved it, right? We're just going to return back this. But we have something we need to pay attention to. What happens when we hit 0? Well, anything times 0 is going to be 0. So this method would actually return 0 for all results, because as soon as we cross 0, we'd have a problem. In factorial, as best we can describe in elementary mathematics, is for positive integers. So we can't go to the negative either. So we need to control for this. So how do we control for this? Well, we need our friend, the if statement. Remember, we need to set our base case. 0 seems to be a great candidate for our base case. So let's put in an if statement here. Let me move all this over here. And let's put an if statement on this. So if what? Well, if our n is greater than 0. So if n is greater than 0, go ahead and return n times n factorial minus 1. Otherwise, return 1. Because if we have a negative number, well, we've got an issue anyway, so we'll return 1. And if it becomes 0, well, then we've reached 0, and we return 1, which will bring us back up the list. Let's do a quick trace of this. So here we'll keep track of n in our stack. And again, I'll keep track of n factorials. So let's do our simple case again of factorial of 3. And we know what our expected output is. So we'll go ahead and make sure we match our expected output of 6. Well, we don't want to make sure. We'll hope that we match it. Let's see how we did. So we have our n value. We're going to call factorial of 3. I'm just going to abbreviate it with fact here in our method call stack. Factorial of 3, our n is 3. Fantastic. Is 3 greater than 0? Yes, 3 is greater than 0. So I'm going to return n times factorial of n minus 1. Well, I can't do this multiplication yet until I finish my factorial of n minus 1. So I'm going to call an n minus 1 of factorial of 2 here. So I've started a new factorial, and my new factorial has an n of 2. And 2 is greater than 0. Fantastic. I'm going to return n times n factorial. Well, I can't do that yet because I need to finish calling factorial of n minus 1. So I'm going to call factorial of n minus 1. Factorial of 1 now. I start up a new factorial of 1. I get a 1 in there. I check my n. Is my n greater than 0? Yes, my n is greater than 0. Fantastic. So now I am going to call another factorial of 0. My n becomes 0. And now I check, is 0 greater than 0? No, 0 is not greater than 0. So now I skip over this first return. I go to the second return statement, and I return 1. So now I am going to return, and we'll go ahead and say return here. I'm going to return 1. So now this becomes more like a t-trace. So now I return 1. And my 0 factorial call is now done. This is over with. So now I move on to my 1 factorial down in this trace, and I can continue my n times factorial of n minus 1. Well, what is my return from the previous call of factorial of 0? It's 1. So my current n is 1. My return from the previous call is 1. I multiply those two together and return that value. So my new return value is going to be 1. My old return value is now gone, and my factorial of 1 is done. Now we're in factorial of 2. So my n is 2 here. My factorial of n minus 1 returned 1. I multiply these two together, and I get a new return value of 2, and my old return value goes away as I finish factorial of 2. Finally, I am here at n times factorial of n minus 1 in factorial of 3. My n is 3. My return from the previous method call is 2. So I multiply 2 times 3, and I get a final return value of 6. The 2 is now gone. Factorial of 3 is done. And my final answer is 6, which, thank goodness, I did it right and I didn't mess up. 6 matches 6, and we get our answer. So factorial is a classic computer science problem that we can solve recursively as the problem gets smaller and smaller each time we go through. We just have to make our base case at 0 and do our simple stack trace. This is the basis of a kind of question that you would see in the AP exam. You're going to need to know how to do these traces. Don't try to do it in your head. Factorial is an easy one. We all know what it is, but be sure that on the AP exam, they will have things more difficult. I have an example of factorial down below. I also have an example of how you can solve it with a simple loop in Repl.it and a copy of these notes for you. Take a look at the links down below in the description. I'll see you in the next lesson.